Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about what to do on moon now. So let's dive deep into it. Now we have already discussed the current new space race is going on. Now you have to understand what China is planning to do is basically Apollo 2.0. Basically they are doing what USA did in 1969. Again with better technology and all that. So we do expect 4K video out of it, but nothing fundamentally more different. It's just going dip and coming back. However, Artemis was built with completely different goal. Artemis was fundamentally like, okay, what are we trying to do? That is much more different than what China is trying to do. So even if let's say China becomes the first in this race, technically it won't be an issue simply because it will like, yeah, you caught up to us in 50 years or 60 years. So yeah, that's not an issue. But it's like building a lunar base is the whole point. Basically, same way we have a base in low Earth orbit, which we call ISS. That's the same point. We want the same base on moon surface, not on moon surface. And the aspirational goal, which again, this is what we are working towards. The aspirational goal is permanently inhabited by people. That's the aim. Meaning, same way we have always, like since ISS was deployed and properly built, it always has somebody inside. Same thing on moon. Permanently, meaning you will have rockets going in, rockets coming out. There will be 5 people, there will be 7 people, whatever have you. That's the aim of it, meaning there will be a permanent base, exactly same way as we have in South Pole and North Pole. Again, it will be a bit more remote, so to say, but that's the aim of it. And then eventually it will grow into a system. Basically, we are going to plant a seed of actual human habitation on moon. That's the aim of Artemis. Like that part is very clear. And while USA is behind schedule, given the fact that Artemis is supposed to land on the moon by 2024 and they burnt $100 billion, give or take few billion. So it's like they are running behind schedule and they have messed up royally with SLS. However, that being said, they have a very good pipeline to the moon, and that is their biggest advantage in contrast to China, so to say. Meaning, not only they can go to the moon, that's the easy part, going to the moon. We did it in 1969. It's just they can keep doing it again and again with high cadence. Money does not buy time basically, but it buys speed. So if you have a rocket company that can give you high cadence, meaning, oh sir, we can launch a rocket to the moon. Okay, when would be the next launch? 1 week later, shut up, take money. Shut up, take money. So that's what SpaceX offers. This whole pipeline that is being built for Starship, that's the core advantage of it. It's not magical rocket. It's just that it's quick. We got it. We're quick. And again, they can be even more quick if they let go of this idea of refueling second stage and putting third stage on a second rocket and launching third stage into orbit, docking it with the payload department. Ta-da! It would be far more logical. 2 launches, go, same tonnage. But no, we're going to refuel second stage. That's the most dumb idea I've seen. It's the second, it's just behind or ahead of that flat heat panel, which again, I realized that most likely it's because of the law. They could not have dug there. So they were like, okay, either delay the project or just build a flat water plate. And this is China's private players directly copying this whole idea. And I'm like, I get it why China's government is not, because again, government did have a plan and you cannot just dump it. That's why this is taking so long. This is a completely new idea. So this new idea, they are after 2030s. They are not expecting this to be ready anytime soon. So this is like, okay, some private players are looking into it. They're working on it. China is helping into it, but money is a bit more private compared to, China's main workforce. So this is the new space race, and again, technically USA is already won. It's just that they have to make sure that they can keep the lead. So instead of just like, oh, you can go and come back, no, we can go and we can stay. So that's the new space race. So one is so ahead that they're like, we want to maintain our stay, and another is like, we are actually catching up. So let's see what happens. So what about landing? Now, landing, we do require different characteristics compared to Apollo era. Apollo was like, bam, Apollo 12, bam, Apollo 14, bam, Apollo 15, Apollo 17, Apollo 11, Apollo 16. And you're like, okay, all of them are from this side. Yeah, it was like, again, there was some geological analysis done and they did collect rocks. So they were like, okay, what if we collected from different varieties? That's cool all, but there was not depth of thought put into it because it was. So this time it's completely different. The laws and constraints that will be put once you actually want to put a permanent habitat, that's a bit different. So what are the prime real estate here? So prime real estate is permanently shadowed regions, or PSRS. These puppies basically on the South Pole. There are some of these puppies who have crater rims that are so high up. Basically, asteroid went boom into it, and if the rim crater was so high that sunlight never reaches in the bottom part, and that's our sweet spot. Hopefully, the aim is that while there is more than enough water on lunar surface, it's just that it's so sparse, it's useless. It's like, oh, there is gold in seawater. It's just that ppm is so low. No, it's a ppb, parts per billion. It's so low, it's like it's useless. So we have water, that's not the issue. It's just that we need concentration of water that is high enough to be worthy in order to extract it. So hopefully right now our aim is that PSR should have that. Now there was a rover that's supposed to actually go and touch it by drilling into it, but that rover is stuck, so we still do not know how much water we are talking about. But again, that's our hope. So that's our primary real estate. Another aspect is there is another romantic point known as peak of eternal light. Yeah, Europeans apparently named it. It's very romantic. And this puppy has long solar day. How long the solar day? Yeah, the idea is if you are right, 24 into 7 into 365. There is no shadow area there. So if you are at the precise point of that crater or peak of eternal light, you just put a solar panel there and that done. You don't have to worry about anything. It's just like done. And again, is that desirable? Is that absolutely 24 into 7 into 365? No. There are some equinoxes, so to say. There are certain scenarios where the sunlight will be very weak. But if you launch there, it's almost like putting a satellite in geostationary. You only go through 1 hour of, Earth eclipse, so you have to run on battery. Benefit of putting solar farm there is that your battery farm would be much smaller compared to if it was like, trying to jump over the lunar winter. So a lunar night, so to say. So that's the prime real estate from power point of view. So both are very close to each other, but we cannot land there, even though right now the G spot is Shackleton Crater Rim. That's the G spot. We want to land there, but we cannot because it's too risky. It's like if your rocket is off by a few meters, if your rocket is off by a few meters on this end, so we cannot actually send human-rated craft there. Although I do expect them to drop some rovers, or if it's Japan, they might actually snipe that directly. And okay, so all this is about real estate. Who gets the claim on it? Now, back in the race number 1, there was no issue about that because USA has claims and Russia does have some claim. They do have some probes there, not that much, and no human one. So Artemis Accord was finalized recently for this exact reason. Who owns what? Well, the idea is priority of access is the first doctrine, second doctrine is first use doctrine. So idea is basically first come first serve. You will land there, nobody will touch it. USA will not touch it, and again they expect you to do the same. For example, India landed Chandrayaan, so that area would be like, India got this, ISRO take care of this area, and Apollo sites, USA. And again, these are almost sacred to USA. So if anybody goes boom boom on this, USA might actually go boom boom on your country. So thou shall not do that. And that's the whole point. That's why planting flag is so important. And that's the whole aim of Artemis Accord. Meaning there is also constraint for a safe distance. Meaning if you land there, let's say rim of Shackleton, Japan lands something there. Does that mean they control the holes? No. There is a safe zone. Basically, they can still do things. And this is why USA is working so hard on having throughput. If you are wise, you will have enough throughput that, oh, you take an air this area, let's say 100 meter diameter. Okay, cool. Everything other than that is ours. So basically, you will cover it. So that's why they do need that thick pipeline going there. And planting flags are very important. And just minor things for some people were like, oh, moon landings were fake. Yeah, the reason nobody takes that seriously is simply because every space agency, including ISRO, including China, including Soviet Union, everybody has seen where they are. Like if you have any sort of probe that is doing lunar mapping, you will see it. All the sites, you will see it. Heck, this is so easy that when they actually landed there, they put retro reflector there, high quality retro reflector. So they tell you a very simple thing: have a laser, have a telescope, align them properly, fire the laser on the moon. Some amount of photons will come back, but you will know, like you'll fire the laser everywhere, aim wherever you want to aim, and you will get a return signature. Calculate that. Okay, cool. And then fire it exactly where they are saying, and at that point in time, you will find return would be exponentially higher, or non-natural return signature, aka it's a human-made object there, or retroreflector. And that was dropped there to calculate basically distance from Earth to Moon precisely. and it's very precise. And that's how we know that moon is drifting around, I think, 1 inch per year, so to say. There's so many of that. You can do it. So it's a university level project. So I was like, oh, it's fake and all that. No, trust me, every other country wanted that to be fake. It's just like, damn it, they used to have brain back in the days. So that's the landing part of it. Okay, what do we need to test for these things? A lot of things, because yes, deal. All the older mission is literally like land in the day, yeet out of there in the daytime. Do not go from whole day, basically 60 days kind of stay, 70-day kind of stay. They were not trying that, because again, that will go into the cold and hot, so not recommended. So for long duration mission, which is what we are expecting right now, there is a lot of real world testing needs to be done on moon. We cannot test it on Earth. We cannot control the gravity, so we can't test it on moon. Basically, we can't test it on Earth, or any simulacra will be good enough for that. Spacesuit, that's the first line of defense. We must have a quality spacesuit. Now, what about the spacesuit from 1969? Yeah, those were hopes and dreams and duct tapes. We need something bit more engineering based rather than hopes and dreams. So that has to be there. And the primary real estate this time is in spacesuit having a poop place. Thou shall be able to poop properly. And yes, this is how ridiculous they had to do in Apollo era. They did not had a proper bathroom. So this time they have to make sure there is bathroom. I do have hopes on SpaceX, given the fact that there is a tiny bathroom in Dragon capsule. So I'm pretty sure they will put a bathroom in lunar module. And you have to, because again, we have dropped poop bags on moon. And right now this is real estate, because this is the only biological sample we have that is outside of Earth's magnetosphere for long enough duration. It's in a bag, so it will be protected. Yeah, from a lot of low energy radiation, of course, it will be protected. But what about high energy radiation? X-rays, gamma rays, cosmic rays, high energy particles. Those puppies are like, bruh, that bag is like going. So what actually happened to the microbiome? So it is like very high priority right now. They want to collect it back. And again, from a biological point of view, I do get that. But again, we cannot sustain this. We have to have a toilet there, proper toilet. So that's there. And rovers for multiple mission, because the rovers that was sent almost use and throw, almost. Okay. Inherently, it was not designed to like, okay, we have this one landing site, we're going to drive to the second landing site. No, but this time it will be designed that way. It's like, oh, you have landing site number 1, landing site number 2, and let's say every landing site is carrying their one rover. So that rover will carry, let's say, astronauts to landing site number 1 from number 2 and bring the rover back. That's the whole point. You will supposed to have a fleet of it. So rovers that can last multiple systems, airlocks, and again, how many times we are going back and forth would be exponentially larger, and again, stress would be higher if you are going through day and night cycle. So all of that, and proper dust mitigation, not hopes and dreams. We can do anything brute forcing it. It's just that, can we do this for long term? That's where the problem begins. So these are the testing vectors that we have to sort in right now. Basically, you land there, what are you testing? You are testing these things. Now we come to the most real part of it, or my lovely parts. Regolith melting. Basically, humanity cannot touch Mars or cannot even dream about anything serious unless we do this. So why do we need that? Well, shielding. Shielding is one of those things where Mars is your friend. Now, problem is Mars is not your friend when you are dealing with a rocket. So while you do want to send 100 ton or 200 ton, you do not want to send 100 ton or 200 tons of just bulk material that is shield. That is no-go. No bueno. You cannot do that. So what is our other option? Well, in situ. No matter what you do, no matter what rocket you have, you will never want to carry shield material. Thankfully, there is material on moon. So we have to do in situ utilization. Now, what are the primary benefits of doing this hassle rather than just relying on the capsule that we have bring there? Capsule is good, but how long it will last will directly be proportional to how much shielding it has. Now, can we have better shielding than what we did last time? Absolutely. But you would not be able to rely on it for years. And again, we are trying to do like ISS. You put it there, you forget about it, and it's there. So to do that, we need to protect against 3 core things. Micrometeoroid shower. Now again, benefit is that it's so high speed that even if you have some material out there, it will shatter and turn into dust. So protecting against it is ironically easier. But again, you do need mass for that. And then you have radiation. Now, will that eliminate all the radiation? Hell no. But radiation is one of those things. It based on doses. For example, if you are only there for 15 days, you can survive. If you are there for 90 days, ooh, not good. So reducing radiation exposure in your habitat is a primary goal. So reducing radiation. Another aspect is if you can cover the, let's say whatever craft you landed there, you cover this puppy up in a thick layer of regolith. What is the benefit? Well, temperature swings will be disappear for you. Now, Sometimes people kind of over exaggerate it. Oh, the moon has so much temperature swing. Yeah, that's not an issue. It's like, why? Well, it's a vacuum. It's not temperature swing as on Earth. Basically, if you have a giant rock on Earth, it cracks because of, again, day and night heating and cooling. But that same thing does not happen on moon. That's why it has so many boulders. And again, particles are so sharp because energy coming in and going out is going through the least efficient method known as photons. Photons are coming in and photons are going out. And again, because how it's spinning, basically sun from its vantage point, sun is not like there is no shadow, vabam. It's like slow. So the flux, basically the high and low, is very smooth. That's why things are still there. That's why things we left there is still there. And again, we know we put a retro reflector that did not disintegrate. So this idea of is like day and night is super hot and cold, that's not an issue. Especially if you know how to make a good quality white paint, it's not an issue. Again, it is an issue for electronics. Electronics do not like that. But things like structure, that's like, brah, I don't care. But if you have thick shielding on that, you reduce even that strain on it. Now you can, it's like, hey, we can trust this puppy for 50 years. We cannot trust the ISS for that long. Why? ISS is going from getting roasted by the sun, getting frozen by Earth. Roasting, freezing, roasting, freezing. Not good. It cracks. But you have thick layers, like meters thick. Then it's like, brah. The night temperature barely drops, day temperature barely raises up. That's the desirable. Now, Regolith is free, that's the good part, and we have to just melt it. Now, to achieve what? Melting it what? We are not smelting it, not getting minerals out of it, we are just melting it to make stone. Exactly how concrete is made, so to say. So that's the aim of it, creating stone structures. And again, some European designs have the idea that they're going to make interlocking brick structure where just like this is the brick, you put one brick, put another brick, and you can make any 3D structure out of it. So that's approach is there. My personal favorite approach is this having a robotic arm with a laser on the other end or a microwave. Now some companies are working on laser end, some are working on microwave. The benefit of microwave is that it does the coupling efficiency higher, meaning if you have 1 kilowatt of battery, 1 kilowatt hour, let's say 1 unit, how much energy you can dump into the microwave, that's much higher. Basically your stuff will heat up more compared to if it was done by laser. Laser is very wasteful, so to say. So these two tools are there and it has to be tested, which again we're going to test both of them, what works the best, and then we're going to go forward with that. And then platform with hands with end effector, basically arms and end effector. And this is like a design that they have done where it's like we do know what a lunar surface is made out of. We have simulate we cannot simulate that sharp edges, but actual composition, we got it, we sorted, we know what will happen. Oh, and there is second benefit. If we actually do this in an indoor environment, this will give off free oxygen. So that's there. So idea is that they're going to melt it and make structures out of it. Now, this company that is trying to do this, they are making glass almost volcanic glass. Problem with that, while it is good and it is a very large surface area, it cracks very easily. So it's good, but not very good. And I've seen other company that is trying sintering. Basically, they are just melting a grid pattern, almost like 3D laser metal printing works. Same thing. And again, it has its own pros and cons. One company is doing something very interesting, where it's like they have a laser, they melt it, very tiny spot, they melt the hell out of it. They're actually melting it. But here's the deal: there will be a lot of gas trapped. Okay, then they remelt it. Basically, you have let's say this is stuff you want to create a border around it. Cool, you melt everything. Okay, cool. But then you remelt it. Basically, the idea of remelting is basically you vibrate it enough, dump enough heat that it becomes liquid enough and gases bubble can come out of it. Benefit of that, now it's a solid stone. The density, the intermolecular density would be almost like solid rock. That will hopefully will give you hard rock. Instead of fragile rock, it will give you hard rock. So benefit is, if you can figure it out, like be it microwave, be it laser, be it this design, that design, whatever have you, once we can do this, then we can actually build landing sites. Then we can build roads. Like, do we need roads? Yes, we need roads. If you want your rover from A to B, you do need roads, especially if you have sites, multiple sites, which we're gonna have multiple sites. So you're gonna need roads. And again, if you have this sort of ability, then only you can build a structure around your habitat to properly shield it. So this is microwave system, this is laser sintering, this is like bulk melting. Although they are melting very thick area, like almost a centimeter, like 2 centimeter deep. So this is their pattern design. So the Regolith melting is the first thing they should do. Like if anybody in Artemis 3 has a long-term plan, this will be like, okay, carry a like 5-watt laser, carry a 5-watt microwave emitter, but do carry the damn thing and test the damn thing. Because once you have that real world data, how it works in actual vacuum of moon, once we can figure it out, Mark 2 will be ready. So what are the priorities here? Well, priorities wise, a very stable comm networks needs to be there, right? The old days of 1969, where it's like once the module went in the dark side of the moon, no communication, and then Transformer movie made a movie out of it. So that cannot work. And China did have a very clever orbit plan, which I did not even know that you could do that, is that it's orbiting a Lagrange point in such a way that it's looking at the dark side of the moon and it's looking at the Earth, same vantage point, 24 into 7 into 365, meaning one satellite gives them full coverage from Earth to this. And I'm like, damn, that's good. Now, again, USA can also do the same thing, and they will, but they will need few satellites to coverage, because again, if you want long-term reliability and sustainability, you do need few things. You do not want one satellite, one failure, poof. No, you want at least 3, 4, 5. And again, it also helps in geolocating. So you do want more than plenty, let's just put it that way. And robotic operations, again, having that laser melting. Now, like, what about latency? Latency is there, but it's not that bad. If done correctly, we can get the user to actual stuff latency down as 2 seconds, even lower than that. And if you are doing that reliably enough, where it's like, no, it's exact 2 seconds, you can work with that lag. So that does require that. And we must learn how to build in situ. Like, unless we can do this, basically you land your stuff and then cover the whole thing, only then I can see, oh, we have habitats, and then it's like, yeah, that habitat will be there for 50 years. And again, this design is sloppy because you're not supposed to have anything that is man-made exposed to the outside vacuum of space. Meaning, if this thing heats up, photons jumps into it, photon leaves it, photon is leaving directly into the vacuum of space, it will freeze. It will go down too much in temperature. You do not want that. You can have insulation, white painting and all that, or you can just create a shade around it. So photon jumping from the structure will come back. Again, you will still cool down, but not that badly. Unless you are seeing, like, this is one thing you have to know. There is no cold. Unless photon can go away from you, you will not go down in temperature. And you will make sure the photon does not get in. Basically, create a shadow tunnel, so to say. Once you have that, then I can expect that airlock to work for, half century, so to say. Assuming dust does not destroy it. But again, you can make sure that it can last that long, or even longer than that. If you have like a really good temperature control, which again, you may even put one RTG so temperature never swings, there is no up or down, then I can easily expect these things to last very long time. Although electronics may require replacement and toilets, but it can be done. So without learning to build in situ, we do not have endurance. We are just going, tweet, tweet. That's not desirable. And making structure is first priority. So Artemis, if they're not prioritizing, we are doing science, no. Build the goddamn thing and plant boatloads of retroreflectors so we can do autonomous landing. So that's the priority. And again, I like this design of astrobotics of having rovers with solar panels so you can chase the sun. And that's also very clever. So this was my presentation on what the heck to do on moon once you actually land there. Now, hopefully you have liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.